Okay, so today we're going to talk about implicit differentiation, and sometimes it's good to kind of have the discussion of what we know so far, or at least what we think we know. In single variable calculus, often we have the variable x, and x is usually the independent variable. Okay, and y we usually has that be the dependent variable. Okay. Um, if we were to solve for the derivative of x, that would usually be equal to 1, or if it was x squared or something else, we could use the power rule or something else to solve for that. And the derivative of y would be y prime, which is usually equal to dy dx. And usually the bottom would be whatever the independent variable is. If we're using u, for example, this would be dy du. So those are just different notations that came around from the birth of calculus. Newton had come up with the prime notation, I believe. Anyway, let's continue. So sometimes when we're solving for an equation, we actually can't come up with an explicit form of dy dx in terms of only x. We actually have to have some y terms in there as well. And this happens a lot in differential equations, and it happens in a multivariable calculus very often also. So anyway, let's just try and see if we can work through one or two examples quickly. So let's say we had it where we had x, y plus, let's see, x plus y was equal to some number, let's say it's 5. Okay. So one might think, okay, I'm going to try and get all the y terms to one side and, do some stuff and do this and whatnot. In this case, you can't actually express everything on one side of this equation, y on the other side. You cannot get it in the form of y equals some blob with some x stuff and some integers and whatnot. So this cannot happen in this case. What we need to do in this case is we need to implicitly differentiate all of the terms of this, and you can actually differentiate not unlike you would divide both sides of an equation or multiply both sides of the equation or add something to both sides. You can differentiate all the terms, and it actually works out algebraically. It's a really cool thing that you can do in that regard. All right, so let's see, let's take a look at this. So we discussed earlier that the derivative of x is going to be 1. So if we use the product rule, we know that that's the derivative of the first term, in this case, the derivative of x, which is 1, times the second, which is y, plus the first, which is x, times the derivative of the second, and let's use the y prime notation. Okay? These are equivalent. We can write that at the end, that it's all equal. Okay, plus, now we're on to the second term here, x, and we know the derivative of that is going to be 1. On the third term here, we have y, and we know that the derivative of y is going to be y prime, so plus y prime is equal to derivative of any integer, which is a constant, is going to be 0. So it doesn't matter if this is 99, 152, negative 8, any integer will have a derivative of 0. So all right, so we've got a couple y primes in here. We can probably factor and clean this up some. So we've had y prime, pull that up front. We know that, see, sometimes nice to underline all the things we need to do. So we have here and we have here. So this is just going to be 1. So y prime times 1 can be equal to y prime. So we can cross that out. Y prime times x. Okay, so y prime times 1 plus x. That gives us that stuff. That takes care of those terms. Figure out some really good system of crossing out things when you're done with them and keeping track of what you're doing while solving some of these problems can really help you with the algebra, by the way. Then we have it where we have this term here, the 1y, so we can have that on the outside of the parentheses plus y, and then plus 1 is equal to 0. We can obviously pull things over to this side of the equation. It's going to be equal to negative 1 plus y There we go. So we subtracted the 1, we subtracted the y, took them over there, put the negative side out front, and then we're going to divide the whole thing by this 1 plus x. That takes care of that, so we get y prime is equal to negative 1 plus y over 1 plus x. And if we wanted to, we can then say that that's also equal to dy dx, just to cover all of our bases. This video is getting a little bit long. I'll cover some more implicit differentiation problems in some follow-up videos. If you have any questions, feel free to post those in the comment section below. And as always, thanks for watching.